So the second part of the chapter is about air. The topic is air and water, but the subtopic is about air. So these are the learning objective. The composition of the dry air, you should know what is the composition of a dry air. Air contain about 78% nitrogen, 21% oxygen is there. Then rest is a mixture of a noble gases as well as carbon dioxide. Carbon dioxide is about 0.04, but the rest remaining is of noble gas. Then the fractional distillation of air, as we discussed, if you want to separate the miscible liquids or gases, gaseous mixture, if you want to separate, what we can do fractional distillation. So if I want to obtain nitrogen, oxygen, or other gases from the air, then we carry out a fractional distillation. This is a fractionating column, the whole apparatus shown. So what we do, the fraction distillation of a liquid air, separate the oxygen and nitrogen, then oxygen boil off around 200. uh, Oxygen boiling point is higher than nitrogen. So first what we do, this is the block diagram. First we pump the air into the chamber, and then we remove carbon dioxide and water. What is the reason why, even though carbon dioxide is a part of the air, but we are removing carbon dioxide first? What is the reason why carbon dioxide is removed first? Because carbon dioxide sublimate. Sublimate means it will convert directly from gas to solid. So carbon dioxide cannot be liquefied. We cannot convert into liquid. So that's why we have to remove carbon dioxide. So how carbon dioxide is removed? Because carbon dioxide is acidic oxide, so we can use a base to remove this carbon dioxide. And then water vapors. Why we remove water vapors from the air? Because the percentage of the water is not same or constant. It vary from place to place. Like at a coastal area or near a seashore, you will find that the percentage of the water is much higher as compared to a dry land. So we remove the water. How we remove the water? We use a drying agent to remove the water so it can absorb the water on the surface. So now air, in the beginning, air contained nitrogen, air contained oxygen, it contained xenon, it contained argon, it contained krypton, it contained carbon dioxide, and it contained water vapors. But we remove two of them. We remove water vapor and we remove carbon dioxide. Because why carbon dioxide? It does not liquefy. And why water? Because it is not constant. The sample amount of water is not constant in the sample of air. So we have other gases. So these gases, what we do, we compress them. As a result of a compression, the gases cool down, and when these gases, like, and this reaction, this way continue, like we compress, then it loses energy, then again we compress, it loses energy, we compress, it loses energy, and the process continue until it is so cold that it turns into a liquid state. And a liquid air is blue in color. The color of the liquid air is blue. What is the reason why the liquid air is blue in color? Because oxygen liquid is blue, or liquid oxygen is blue. That's why the liquid air is blue in color. And then we have a fractionating column. So at different temperature, we obtain these gases. So this is how we carry out a fraction distillation of air. So you have to understand the fact, you don't have to learn the whole procedure of fraction distillation. You just have to understand the fact that, or learn the fact that if we want to separate the nitrogen and oxygen from the air, the technique which we use is known as fractional distillation. Nitrogen is not having any color. Nitrogen is a colorless. Only the colored gas here is oxygen, which is blue in color. Like oxygen liquid is blue in color, which make this whole, the liquid air, turn to be blue because of oxygen. Then about the air pollutants, because there is a air pollution. So some common pollutants are carbon monoxide, sulfur dioxide, and oxides of nitrogen and lead compounds. Carbon monoxide, what is the source? How it is produced? By incomplete combustion. Like if there's a limited supply of oxygen, then carbon monoxide is produced. Sulfur dioxide, there are fossil fuels like coal, even they contain some trace of sulfur. So when we burn the coal, it also produces sulfur. It produces carbon dioxide, but it also produces sulfur dioxide because some sulfur is also present. Oxides of nitrogen, it is produced in the car engine, and the lead compounds are present in a leaded petrol. We will discuss all of them in detail. This is just a intro of the topic. So first, state the adverse effect these common pollutant to the health and to the global concern. So carbon monoxide. Carbon monoxide is a poisonous gas or a toxic gas, and the problem which it causes, that is cause a suffocation. Because if the carbon monoxide, when it is absorbed, it has a like a blood will absorb more carbon dioxide than oxygen, and that will reduce the amount of oxygen in the blood, and it can lead to suffocation or death. Then sulfur dioxide, it is formed from it can form an acid rain. How acid rain? Like when we burn the sulfur react with oxygen to form sulfur dioxide. Then this sulfur dioxide mix with the so sulfur react with oxygen, gives sulfur dioxide, and this sulfur dioxide mixed with water in the atmosphere, and it will form H2SO3, the sulfurous acid. And this acid, when it rain, what will happen? The water is not now become acidic. It will have a pH less than 7. So this acid rain can kill plants or aquatic life because it will make pH low. It can erode the stonework because like stones work or calcium marble work, marble or calcium carbonates can react with acid, so it can erode the stonework, or it can corrode the metal, like structures which are made up of the metal can be corroded due to this acid rain. Then oxides of nitrogen, what happened? This is produced in the car engine, inside the car. So because the car is using a combustion or a burning, so inside the engine, the nitrogen and oxygen from air react and it forms oxides of nitrogen. And this oxides of nitrogen, it can also form an acid rain because oxide of nitrogen, it's a non-metal oxide, and non-metal oxides are acidic. So it can cause an acid rain, or it because this is brown in color. So when this brown gas or oxide of nitrogen is given off, this brown gas reduce the amount of sunlight enter the earth atmosphere. So it can also affect the rate of photosynthesis which the plant carry out. So react with other pollutant in sun and form a photochemical smog, which can also cause a breathing difficulty or reduce the amount of sunlight, as well as can cause an acid rain. And the last one, like leaded compounds, petrol contain lead as well. So that is toxic. It can cause damage to the brain or to the nervous system. So this was about the air pollutant.